In today's lesson, we're going to be covering multiple representations of linear functions and also talking about how we can compare those functions in those multiple forms. Okay, so first of all, we're given a standard form equation in this first cell of this table, but we should be able to write that equation in slope-intercept form. We should be able to represent it in a table, and we should be able to represent that function as a graph. So what we're going to do is we're just going to take this first standard form equation and talk about what would that equation look like in slope-intercept form? How do we form a table? And ultimately, how do we graph that? And then for the other two examples, we're given different parts of or different forms of the functions. And again, we have to fill in the missing parts. Okay, let's start with the first one. We have a standard form equation of 2x minus 3y equals 18. We've already talked about how to transform that into slope-intercept form, so let's go ahead and do that first. We're going to subtract 2x from both sides of the equation, and we would get negative 3y is equal to negative 2x plus 18. Now let's divide both sides of the equation by that negative 3. We would get y equals 2/3 x minus 6. Okay, there is our equation in slope-intercept form. Now let's go ahead and form a table. So I'm going to pick some x values that we can plug into that function. So I'm going to pick 0 for x, I'm going to pick 3 for x, and I'm going to pick 6 for x. Okay, let's go ahead and plug those in and see what y values we get out. So if we put 0 in for x, that would say 2/3 times 0, which that gives me 0, minus 6, that gives me negative 6. We also could have found that y-intercept just by looking at the function in slope-intercept form. Remember, the b is your y-intercept value, and the y-intercept always has an x value of 0. Okay, let's plug in 3. So if we take 2/3 times 3, that would give me 2. And 2 minus 6 gives me negative 4. All right, last x value I picked was 6. If we take 2/3 times 6, that would be 4. And 4 minus 6 gives me negative 2. You can see why I picked those x values because it gave me whole numbers out for y. Okay, let's go ahead and graph. Now, we could graph the points that we just picked for x and y. We could use the function in slope-intercept form to graph it. There's lots of different ways that we could get that graph. I'm going to be looking at the slope-intercept form and graphing it from there. So my y-intercept is negative 6. Oh, this graph only goes to negative 5. Okay, so I'm just going to mark a point lower on the graph than that negative 5 is, and I'm going to go up to and write 3 and mark a dot. Again, up to and write 3, and again, I'm off the graph there. So my line would look like that. Okay, next example, if we look, guys, it gives us a t-chart, a table, but we don't know either of the two equations. So I'm going to go ahead and graph it first. So hopefully these points will fit on the graph here. We have an x value of 2 with a y value of 3. We have an x value of negative 2 and a y value of 1. We have 0 is matched with negative 4 is matched with 0. 0 is matched with 2. And 4 is mapped to 4. So here is that line. Okay, we've also talked about how to write equations for lines given graphs. So I noticed that my y-intercept is 2, and if I go up 1 and right 2, I get to the next point. So that gives me a slope of 1/2 and a y-intercept of +2. Okay, now we haven't transformed the equation from slope-intercept form into standard form because that one's not a typical transformation, but we could. We want to move x's and y's over to the left side and leave the constant on the right. So I'm going to subtract 1/2 x from both sides. That would give me y minus 1/2 x is equal to 2. Now, to clean this up a little bit, we do want x to come first, and x we would prefer to be a positive number, and we don't want any fractions in standard form. So I'm going to multiply everything through by -2. It's going to switch my signs, make my negatives positive, my positive is negative, and it's also going to get rid of that fraction in front of x. So if I multiply everything by -2, I would get -2y plus 1x, or just x, is equal to -4. And then one more step, we just want that x to come first. So x minus 2y is equal to -4 would be the preferred form for standard. Okay, let me box those answers actually. Okay, last example on this slide, we're given a graph. So kind of similar to the last one, we want to make an equation from that graph. We can make the t-chart from the graph too if we'd like, and we want to talk about standard form. So taking a look, I want to identify some points that would be on this line. So I see an x value of 0 is matched to a y value of -1. I see an x value of 1 is mapped to a y value of 2. And it looks like -1 is mapped to -4. Okay, from that graph, I'm also going to make the equation. Taking a look, it looks like the y-intercept is at 1. And if we rise 1, 2, 3 and run 1, we get to the next point. So that gives me a slope of 3/1, or just 3x. And the y-intercept again was -1. Okay, we're going to transform that into standard form. So again, I'm going to subtract 3x from both sides. I would get -3x plus y is equal to -1. And let's go ahead and multiply that whole thing by -1, so our lead coefficient is positive. So -1 times -3 would give me +3x. -1 times that positive y would give me -y. And -1 times -1 would give me +1. So that would be my preferred form for standard. Okay, in these next couple slides, we're going to be looking at linear functions in different forms, and we're asked to compare them in some way. So with this first example, we're trying to determine which function has the greater slope. In function A, we're given a t-chart, and in function B, we're given a graph. So we've talked about how to find slope in both of these situations. So in function A, I'm going to find slope by using the slope formula. Y2 minus y1 over x2 minus x1. In this particular example, I'm actually given 3 points for x and y. I only need 2, so I'm going to pick these bottom 2 points, the -3, -9, and the 9, 15. Let's go ahead and plug those into the slope formula. So the second y value is 15, minus the first y value is -9, over the second x value is 9, minus the first x value of -3. If we simplify that, 15 minus a -9, that would actually mean plus. So 15 plus 9 gives me 24. And 9 minus a -3, again, minus a negative means plus, so 9 plus 3 gives me 12. 24 divided by 12 gives me a positive 2 for my slope for function A. Okay, for function B, I'm going to go ahead and use the graph and calculate rise and run. So on this particular graph, I see a point at 0, -1. I'm going to use that point. And I see another point at 5, 0. So those are the 2 points that I'm going to use to find the slope. Again, when we're finding slope by the graph, we think rise over run. So taking a look at the point that is on the bottom, I would have to rise 1 unit, and I'd have to run 5 units. So my rise is 1 and my run is 5. So now it's much easier to compare these two because I have numbers to compare now. We see that function A has a slope of 2, function B has a slope of 1/5, and 2 is definitely bigger than 1/5. So function A has the larger slope. Most of the time when we're asked to compare linear functions, it is not just with graphs or the equations, it's actually with word problems. So these next couple of examples are going to go through word problem scenarios where we're asked to compare, again, different forms of linear functions. So the first example says, Sean and Mariana started drinking their slushies at the same time and tried to drink them as fast as they could. Sean started with 300 milliliters of slushy, and he drank 5.5 milliliters per second. The graph of the remaining volume of slushy in Mariana's cup in milliliters, as a function of time in seconds is shown below. 2 questions here. Who drank their slushy faster, and who finished drinking their slushy first? Okay, so first of all, Sean's is given in words, and Marina's is given in a graph. So this is Sean, this is Marina. Okay, so in order to determine this, we have to compare their slopes. Who drank their slushy faster is asking us who had the greater slope. So I'm going to go ahead and write an equation for both of these functions. So for Sean, it says that he started with 300 milliliters of slushy, and he's drinking, so it's going to decrease, the amount's going to decrease at 5.5 milliliters per second. So that's what his function would look like. Y equals 300 minus 5.5x. If we do the same thing for Marina's equation, she starts with, let's see here on the graph, 250 milliliters of slushy. So she has less slushy to begin with. So 250 milliliters of slushy. I have to find the slope of this line, which I see that it is going downhill. So it's going to be negative. But this goes from 250 down to 50. So again, if I'm thinking rise and run, my rise is going up to 250 and my run is going left, so negative 50 units. So I'm going to divide those two, rise divided by run. 250 divided by negative 50 would give me negative 5. Okay, so now we have both in equation format. Very easy to compare here. We see that Sean is drinking his slushy faster. So he's drinking more slushy per second than Mariana is. Okay, so the answer to the first question is Sean. Sean's drinking his faster. Okay, who finished their drinking their slushy first? Okay, well, Marina's, we can see from the graph, right? So when she's finished, she's going to be down here at 0 milliliters of slushy left, and it took her 50 seconds. So Marina, we know, is 50 seconds. It took her 50 seconds to drink all of her slushy. But we're not sure Sean's. But if we think about what this is on the graph, that's my x-intercept. So when we're trying to find an x-intercept, we're going to substitute 0 in for y. So I'm looking at Sean's equation here, where it says y equals 300 minus 5.5x. Let's substitute 0 in for y and solve this equation. I'm going to add 5.5x to both sides. So we would get, and I'm going to write it up here, 5.5x equals 300. And we need to divide both sides by 5.5. We get x equals, okay, we get approximately 54.5 seconds. So we see that Mariana drank her slushy in 50 seconds, where it took Sean 54.5 seconds to finish his. So Mariana finished her slushy first, but Sean was drinking his faster. Okay, the last example for your notes today says Antoine wants to get a subscription to a local library. There are 2 libraries, each of which charges a monthly subscription fee plus a fee for each book loaned. The following equation gives the monthly cost in dollars of joining the first library as a function of the number of books loaned. C equals 10 plus 1.5n. The monthly cost in dollars of the second library as a function of the number of books loaned is given by the following table of values. 2 books is $15.50, 8 books is $26, and 14 books is $36.50. The first question, which library charges more for each book loaned? And the second question, which library has a cheaper subscription fee? Okay, so let's take a look at these 2 functions. First of all, library 1, we have an equation for. That's kind of nice. So I'm just going to circle this first function and label that library 1. The second library we do not have a function for, so it would be kind of nice if we could come up with an equation for it. So let's first find the slope and then we'll find the y-intercept. So I'm going to use these first 2 points to find the slope. y2 minus y1 divided by x2 minus x1. We get 10.5 divided by 6, which gives us 1.75. That is the slope of the equation, so I'm going to label that m. We also have to find the y-intercept. So I can do that by figuring out what would the cost be for 0 books. Or I could pick one of these points. I think I would probably pick the 826 and plug those values in for y and x. I'm going to show that method. So y is 26 is equal to the slope, m, times the x value of 8, and I do not know the y-intercept. I don't know the b. Let's go ahead and solve that for b. So 1.75 times 8 gives me 14, so 26 is equal to 14 plus b. And to solve for b, we're going to subtract 14 from both sides. That's going to give me a y value, a y-intercept value of 12. Okay, so now that we have m and b, we can write the equation for the second library. So the second library is y equals 1.75x plus 12. Or if I use the variables that they did for library 1, they're using c for y and n for x. So the cost would equal $1.75 times the number of books plus 12. This is my function for library 2. Okay, to answer the questions, which library charges more for each book loaned? For each book, that's talking about the slope. So we see library 1 charges $1.50 for each book, whereas library 2 charges $1.75 for each book. So library 2 charges more per book. So library 2. Which library has a cheaper subscription fee? So the subscription fee is the amount that you're just going to pay initially per month. So that would be the $10 for library 1, be the y-intercept, or $12 for library 2. Cheaper fee is library 1 at $10. Okay, this concludes the notes for today.